Hello and welcome to the fourth and final topic in the computational thinking unit for computer science. This one is algorithms. As always, there's a standard starter, which is which of these four definitions is the correct one for algorithms? We've already done the other three, so if you've been paying attention over the last few weeks, this should be pretty straightforward. You've got 10 seconds. Well, the only one of these left was this one, giving step-by-step instructions to solve a problem. That's what an algorithm is. It's a step-by-step set of instructions. We use critical thinking tools all the time, and what we aim for in computer science is to wind up with an algorithm which provides a solution to the problem. It's a culmination of everything else we've done. So, to summarise, algorithms are the fourth and final step in computational thinking, and it's a set of step-by-step instructions to solve a problem. So as always, can you make a note of that first of all? Just give you a few seconds. Write down in your books that an algorithm is a set of step-by-step instructions for solving a problem. Okay. So there are two ways we can do algorithms. The first one is a structured English algorithm. This is the one that's most intuitive, makes kind of sense. Instructions are written out using short phrases, and this example will show you what we mean. So this here is an algorithm for how an online form could work for verifying the age of someone before signing them up. It says get age from user. If age greater than 18, output application accepted. Otherwise, output applicants must be over 18. That's pretty much English. I'm pretty sure all of you can figure out what's going on there. There's no formal syntax for structured English. As long as another person could understand it, then it's all good. They're intuitive, they're easy to follow, they're pretty straightforward. So can we add that to the notes you've just done, to the definition you've just added? Structured English algorithm uses short, structured sentences to express the instructions. If you pause the video and unpause it once you're done with that note. Okay. So here's a task you can do with a structured English algorithm. Don't need to give you much more instruction from this. This is just fairly straightforward. Finish off this structured English algorithm for a pedestrian crossing. So it starts with wait for a button to be pressed. If button is pressed, green light off, amber light on, pause 0.5 seconds. Amber light off, red light on, pause 1 second. Red man off, green man on. Then what? What needs to be the next few instructions to get through to the point where it's once again waiting for a button to be pressed? You don't need to know the exact sequence of how a traffic light works, as long as you've got the rough idea with it. So give yourself a couple of minutes on this, pause the video. Once you've got the algorithm written out, unpause it, and we'll have a look how you did. Okay, hopefully you got something similar to this. Pause for 10 seconds, that's to allow them to cross the road. Then green man off, red man on, and pause for 2 seconds. Give them a couple more seconds to finish crossing the road before the main lights start to change. Then red light off and amber light on, pause for 0.5 seconds, amber light off, green light on. That's pretty much the sequence, but I've ended it by saying go to start, to make it clear that once that's finished, you go back up to the beginning and wait for the button to be pressed again. So that's a structured English algorithm. Hopefully that's really intuitive. You can follow that. It doesn't take much explanation. However, a more common type of algorithm is a flowchart. A flowchart uses shapes and arrows to direct you around the algorithm. They're intuitive to read and very straightforward to follow, and actually can be much simpler for more complex algorithms, although they take a bit of work initially to learn how to design them. Let's have a look at an example. This is a flowchart here, and before I tell you anything about a flowchart, have a go at seeing if you can use it. There's a start point and there's an end point, and the arrows move away from start and towards end, so you can figure out how to get going with it. And the question here is, if the user enters 15, what will be displayed? Have a look at that. see if you can figure out what will be displayed if the user enters 15 following this flowchart. Well, hopefully you started at the beginning and you followed the arrow through here. You got to a question. The answer to the question was no, so you followed the arrow through to the end. And the only box that you passed through was this one here that said output hamster. So hamster is what's going to be output, hamster is what's going to be displayed. The flowchart was constructed using those three shapes, the sort of oval shape, a rectangle and a diamond, and they have very specific jobs. The oval shape only appears at the start and the end of the flowchart. They're called terminators and they just indicate that is either the beginning of the flowchart or it's the end of the flowchart. The rectangle is whenever something happens. Anything that happens appears in a rectangle to say, do this. So an arrow goes into a rectangle, something happens, and one arrow comes out the other side. And a diamond is for a decision. A decision is anything that can be yes or no. So a question is always asked in the decision, and two arrows come out. One for if the answer is yes, and one for if the answer is no. And that's all there is to a flowchart. So before we do some more work with it, let's make some notes on that. So in your book, can you write that a flowchart is a type of diagram that can be used for an algorithm? A flowchart is made up of arrows and the following shapes. And if you copy that box showing us symbols of the terminator, process and decision, and that a terminator is the start and end of a flowchart, a process is something that happens, and a decision is a question that can be yes or no. So pause the video, make those notes, and unpause it again when you're done. Okay. So here's a task, a flowchart here for you to read. Always start at the beginning, follow the arrows down. Every time it gets to a question, you either follow the yes path or the no path. So this is a flowchart for a computer program. And we want to know what will be printed if the user inputs A, 57, B, 149, and C, 20 as a word, T-W-E-N-T-Y. So follow the flowchart, decide for each of those three what you reckon the outputs will be and write them down in your book, and we'll see if you got it right. Unpause the video when you're done. Well, these are the answers. So 57 follows the red line. So when it gets to is it a number, it follows the yes path because 57 is a number. When it says is the input greater than 100, it follows the no path because 57 is not greater than 100, and it prints not enough before making it to the end. So not enough is the output. When 149 is input, we follow down to is the input a number? Yes, it is. So we follow the Y path. Is the number greater than 100? Yes, it still is. So we follow the Y path again. It prints thank you and ends. So thank you is output. And when we input 20 as a word, we get, is the input a number? No, it's not. It's a word. So we follow the N line through to print the error and then through to the end. So error is the output. Hopefully you got those three. Flowcharts are often very straightforward when describing loops, something that isn't as easy with structured English algorithms. So if we look at this one here, this is for getting a PIN number from a user. In this flowchart, what happens if the user enters the wrong PIN? The correct PIN is 1234. It's asked down here, does the PIN equal 1234? What happens if they put the wrong PIN in? Well, if you look at this, you should notice that it follows along that line to flash a red light and then goes back up and rejoins earlier on in the flowchart. So it then asks for a 4-digit PIN again. So this flowchart may never end. If they never get the PIN right, it will stay going round that cycle over and over indefinitely. So in other words, it will never get to the part of the program where they manage to continue with it unless they get the PIN right. And that kind of loop is very easy to follow on a flowchart. So the last major task for you guys is to create your own flowchart. So using the symbols and rules that we've looked at so far, I want you to create a flowchart for a password checker. So this is what happens. The user enters a password. If the password is pig, then the system says access granted. Otherwise, the system displays access denied. Okay, very straightforward flowchart. You need to think about starting with a start in an oval, and you'll end with an end in an oval. Then when it does stuff like asks for the password, that's in a rectangle. And the only question this one is going to be is the password pig? And if it is, go in wrong direction. If it's not, go in the other, and then tell it what to do. You should be able to draw a pretty convincing flowchart for that. Pause the video, unpause it when you're done, and you'll see if you end up with the same thing that I came up with. Okay, well, this was my solution for it. We start here, we enter the password, then we ask, does the password equal pig? If it's yes, we follow along this arrow and it displays access granted and then goes to the end. If it was no, it follows this arrow and displays access denied and then comes to the end. Now, you may have had the arrows coming out of different parts of that diamond. That's all fine, as long as it follows that pattern. Now, at this point, some of you will be feeling really confident thinking, I've got this. I fully understand flowcharts. I'm pretty certain I can answer any questions on it. If that's the case, feel free to skip this, go straight to the blue assess task and do that. If you're still a little concerned about it, there is a link on the VLE to a site that steps you through in really nice, easy incremental steps to get in the hang of flowcharts. So if you're not sure about it, I'd suggest you do that first. That will really help you with it. Then when you're done with that, you can come back to here and carry on with the assess task. Whichever route you take, the assess task is, as always, complete the quiz on the VLE. And if you've done that, and there's time left in the lesson, your extension is to create a flowchart for a program that gives the user 3 attempts to enter a password. This is pretty advanced. Some of you will be able to do this, some people won't, that's fine, but it's a nice challenge to have a go at if you're feeling pretty confident about flowcharts. If they get it right on any of the attempts, it displays access granted and stops asking. If they get it wrong 3 times, access denied is displayed and it stops asking. Now the solution is much simpler if you use a loop, if you have an arrow that goes back to higher up in it again. Okay, so do the quiz, do that if you can, upload your work, and I'll see you for next week's lesson. Thank you, bye-bye.